Okay, should we start again?
Sure.
Let's do it. Hi, everybody. My name is Michelle, and I'm in my 5th/final year of electrical engineering.
And my name is Nishita, and I'm in my 3rd year of electrical engineering.
So a little tiny bit about the engineering program, because I don't know how much you have heard about it yet. It's 4-ish years, give or take. Your first 2 years are general. Everybody does the same pretty much courses. You can do them at Dow, or you can do them at another associated university like St. FX or Acadia or CBU. And then at the end of your first year, you choose your discipline that you're going to study for a while, although there still is some flexibility. So in electrical and computer engineering, there is the electrical stream and the computer stream. It's under the same degree, but you focus a little bit differently in the courses that you take. And then every discipline has the option to do a co-op work terms, which add 3 or 4 work terms to your studies. So it lengthens it a bit, but you get a lot of valuable experience. And you'll hear about, I don't know if you've already done the co-op session, but you'll hear a lot about it.
So what is electrical and computer engineering? So it's a study of electricity, electronics, electromagnetism, computer hardware and software. So when you think of the bigger, grander side of electrical, you think of power lines, utility makes power, how the power gets to your house. And on the smaller end of things, you'll think about computers, microprocessors, all the small things that you interact with on a day-to-day basis. Electricity is a big part of our day-to-day life. Chances are there's an electrical or computer engineer behind the design of the things that you use every single day.
It's a little bit more on the computer versus electrical side. As I said, most of it is the same. It is the same degree, but you focus a little bit in the computer side, you focus more on computers and software versus the electrical side, focus more on power, electricity, and hardware. Here are a bunch of courses that you take that are the same. And then the differing ones, computer architecture and operating systems, you take as a computer engineer, and electromagnetic field and power systems you would take as an electrical engineer. If electrical is maybe something that you're interested in high school, you would want to take your calculus and your maths and your physics and your chemistries. And on the flip side, if you are really enjoying those courses, electrical might be an interesting choice for you. So here's a little slide talking about the difference between electrical or computer science and computer engineering, because they kind of sound the same. But basically how it's been explained is that computer engineering is the sweet spot between computer science and electrical engineering, between the hardware and the software vibes. We're both in electrical, so I don't know if we can speak to that, but that's the rumor. And computer science isn't in engineering, but I thought I would include it in our gradient.
All right, so after graduation, you'll probably be looking for a job. So there's lots of classic engineering fields, like going into an industrial setting, electrical utility, communication systems, building design, radio transmission. Those are all very traditional fields that a lot of electrical engineers will go into. There's also other little fun places, like you could create your own startup. You could go into computer design, biomedical engineering, video games, coding, renewable energy. Dow, and specifically the electrical department, offers a biomedical engineering certificate, and that is more of you as an electrical engineer or electrical engineering student could look more into how electrical engineering is applied to the biomedical field. So you learn a little bit about introductory biology, human physiology, and just how electricity interacts with all of those components. So there's lots of options in electrical engineering.
Totally. Speaking of jobs, mentioned about co-op, there's a lot of co-op options. These are just a couple. So I've done 3 so far, 2 at Nova Scotia Power and 1 at ESN since I'm almost done my degree. These top 3 are me in a helicopter doing a transmission line inspection. This was me damage assessment during Hurricane Dorian. And then this is me this summer working in the field, testing a sensor, like outside all day. It was sweet. And then this is like a little example of something that made the code, or the code made that. Like, I was really proud of it. So those are some co-op things.
So I'm just in my third year. I will be starting my first co-op job this January, and I'll be working with the Department of National Defense. And hopefully I'll be learning a lot more about how electricity and power is distributed through the harbor, and how electricity is often distributed to the Navy ships that will dock at the shore. So there's lots to learn for me still.
And some other places you might work. You could work at Tesla, Irving. So you can go down south, or you could go to out west to work in oil and gas, and like stay around Halifax, work in Nova Scotia Power. There's so many options.
So microprocessors are in every little computer or phone component that you interact with on a daily basis. They're essentially just really small computers, and there are so many different kinds. And microprocessors are something that we work with a lot in the electrical and computer labs. So a lot of what we learn is about writing code, learning how to upload it to these microprocessors, and trying to get them to perform the tasks that we want. And that little clip right there is a small LED project that we had in second year as we were playing around and learning how microprocessors interact with the codes that we are trying to implement. And another fun application of microprocessors are robots, which Michelle will give a little demo on.
Woohoo! So in third year, in the summer of third year, you do a summer semester, which is not ideal, but you do get to build a robot. And it's super exciting. So you have to build an autonomous robot that does its own work and navigates a course. So this is my robot finding a metal pipe that was buried under there, like using a metal detector, and then he has to track it all the way over here. Very fun stuff. So this is just some of the design process, I guess, of the code. His name was Jared. This is the OG hardware stuff. This is a printed circuit board we had to design. Another printed circuit board, a signal that came out of Jared somewhere. And then this is a little code snippet. Speaking of code, go do a little demo. Code. So as we mentioned, code is comes up a lot in your labs. You learn C and C++, and then you might learn other ones as you continue your degree / your co-op terms. So this is a quick little code that we wrote. Once you know code, it is a very easy code. This one's written in C. So if we hit run, we'll say, oh, hey, hello world. If you're reading this, it means your code worked. What is your name? So I'll type in my name. It's asking for an input and press enter. And it says, oh, and it takes my name and it spits it back out at me. So it totally read it, totally knows who I am. How old are you? Ooh, I'm 22. Enter. Cool. Takes out or spits out my name or my number. And then my favorite number right now is 5. So if I put 5 in there and it spits out my number, adds them up, gives me 27, minuses them, gives me 17. Super cool. A super easy, quick application of code, but you can do so many complicated, complex things with it. Very cool. So maybe final thoughts. Anybody can be an electrical engineer. It's not that hard. It's not that scary. That's a misconception.
It might seem daunting because a lot of things are very new, but if you have any interest in it, it might be something you want to explore more into, because there's always something for everybody in electrical engineering. Do we have any questions? You can put them in the chat there.
You can turn on your mic, chat with us. Or you can head over to your next session if you're done with us.